Welcome back to Advent of Code 2016, where I continue to get my career destroyed by ChatGPT. Hello, Radiant Up. Alright, so we're on to day 11 of 25. Hello, Kinsoda. Okay, so 11. Here we go. Radioisotope thermoelectric generators. Sounds fun. Oh my god, that's a lot of text. Alright, let's get through this. You come upon a column of 4 floors that have been entirely sealed off from the rest of the building except for a small dedicated lobby. There are some radiation warnings and a big sign which reads Radioisotope Testing Facility. According to the project status board, this facility is currently being used to experiment with radioisotope thermoelectric generators. Got a little Wikipedia article on radioisotope thermoelectric generators. Kind of nuclear battery. Cool. Right. That are designed to be paired with specially constructed microchips. Basically, an RTG is a highly radioactive rock that generates electricity through heat. Okay, that I understand. The experimental RTGs have poor radiation containment, so they're dangerously radioactive. The chips are prototypes and don't have normal radiation shielding, but they do have the ability to generate an electromagnetic radiation shield when powered. Unfortunately, they can only be powered by their corresponding RTG. Okay, an RTG powering a microchip is still dangerous to other microchips. Okay, fine. So if they're powered, they don't get harmed by radiation, but if they're not powered, they do. Okay. In other words, if a chip is ever left in the same area as another RTG, and is not connected to its own RTG, the chip will be fried. Therefore, it is assumed that you will follow procedure and keep chips connected to their corresponding RTG when they're in the same room and away from other RTGs otherwise. But, alright. These microchips sound very interesting, do they? And useful to your current activities, and you'd like to try to retrieve them. The 4th floor of the facility has an assembling machine which can make a self-contained, shielded computer for you to take with you. That is, if you can bring it all of the RTGs and microchips. Okay. Within the radiation shielded part of the facility, in which it's safe to have these pre-assembly RTGs, there is an elevator that can move between the 4 floors. Its capacity rating means it can carry at most yourself and 2 RTGs or microchips. Okay, as a security measure, the elevator will only function if it contains at least 1 RTG or microchip. Okay, the elevator always stops on each floor to recharge, and this takes long enough that the items within it and the items on that floor can irradiate each other. Alright. Oh my god. You can prevent this if a microchip and its generator end up on the same floor in this way. Fine. You make some notes of the locations of each component of interest. So there's how many floors? 4. Okay. What a scary building to work in. Yeah, this does not sound safe at all. You make some notes of the locations of each component of interest. Your puzzle input. Before you don a hazmat suit and start moving things around, you'd like to have an idea of what you need to do. When you enter the containment area, you and the elevator will start on the first floor. Right. For example, suppose the isolated area has the following arrangement. The first floor contains a hydrogen-compatible microchip and a lithium-compatible microchip. Okay, fine. The second floor contains a hydrogen generator, so they're going by elements. So if it says hydrogen for the microchip, then it needs hydrogen for the generator. Fine. So we have to parse this. So if it says hydrogen compatible microchip and a lithium compatible microchip and a carbon compatible microchip, then you would need to separate by the and phrase to extract each element. Okay, fine. As a diagram, the initial state looks like this. Okay. So we've got H generator, H microchip. L generator, L microchip. And we've got E for the elevator. So this column is only for the elevator. Then to get everything up to the assembling machine on the 4th floor, the following steps could be taken. Also, we have to bring everything to the 4th floor. What was our goal again? Yeah, we have to bring everything to the 4th floor. Okay. This looks like a hard problem. Not just wordy, it looks like it's wordy and hard. I think some things, sometimes they can be wordy and easy. Okay. To get everything up to the assembling machine on the 4th floor, the following steps could be taken. So we don't know yet if we need to take the optimal number of steps or just any number of steps. Bring the H microchip to the 2nd floor. And that's safe because it's with the H. Okay. So the rule is, if you've ever got a microchip that is not in the same area as its corresponding generator, then it cannot be with any other generator. So either it's with a bunch of generators, but at least one of them is its corresponding one, or it's with no generators. That's the rule. That's really the only rule. Bring both hydrogen-related items to the 3rd floor. Which is safe. Okay. Yeah, fine. And now we bring the hydrogen microchip back down. Oh, because you're not allowed to use the elevator without carrying some item. Oh my god. Fine. Okay, this is starting to look like it might just be breadth first search then. I was worried it'd be a bit more algorithmically complex than this, but the neighbor states are pretty straightforward. You are at E. You are on a floor. Your option is always to take 1 or 2 items from the floor and go up 1 floor or down 1 floor. Now, a lot of neighboring states can be ruled out because they won't satisfy the rules, so probably it'll be a low breadth. Well, it's always going to be low breadth. There's always 2 neighbors. Well, no, there's not always 2 neighbors. Depends what items you take. But still, it'll be low breadth because a lot of possible moves won't be possible. So, fine. And then we grab the lithium. Then you bring them both up to 3. And now you can bring 2 at a time up. Okay, fine. It's quite tricky to solve by hand, but we can do this with code. It's like the fox, the wolf, the cabbage, and the goat puzzle. Alright, it takes 11 steps to collect all of the objects on the 4th floor. Minimum number of steps required to bring all of the objects to the 4th floor. I think it'll just work with breadth first. There's only 4 floors. And how many items do we have? Oh, is that it? Okay. It's not even gonna be... I thought it would be like hundreds. Okay, fine. It's just a matter of coding it correctly. Oh my god, okay. I don't even need to parse this. We can just type this in manually. Alright. So. So I'm not going to bother using input.text. Okay, so first floor. Alright, let's have a look at these. Alright, let me just copy this in just so we can read it. Strontium, plutonium generator, thulium, ruthenium. There's antimony, arsenic, aluminium, selenium, and hydrogen, nitrogen, and rhenium. Hydrogen and oxygen and nitrogen and rhenium. Curium, thulium. Okay, they've each got a unique starting letter, so we don't have to write out the whole element. We could just say S, P, T, R, C. Okay. Yeah, okay. So, just say... I need to have a think first how I want to represent the data. Okay, let's just try and do this cleanly. Alright, let's say a state. Alright, define a state. Alright, and then on the first floor... define it. self first, second. So these are lists of items you have on each floor. Okay. Third, fourth. Self dot first equals, let's say, tuple first. So you can pass it a list of things. Yeah, okay. Let's sort it just so it's kind of unique. Sorted. That way we can easily compare to states because they're all sorted, so we have equality checks. Self.second equals, so we do this. Text might be a bit small. Let me zoom in a bit. I have doubts as to whether ChatGPT will be able to solve this one. Not only is it very wordy, but kind of difficult to parse the input, which ChatGPT is going to have to do. Alright. Define. No. Class. Class. State. Alright. So that's what our state looks like. We want... Ugh. Okay, fine. We want to be able to hash. So we would just do this. Okay, what else do we need to do? Equality. That should... Let's put this before hash. Okay. So, okay, we've defined a state. We know how to compare to an equal. We know how to hash. One last thing I would want to do is we want to be able to create a copy of a state where we've modified... We've modified it. Oh, how do I do this? Oh, we need the elevator. Let's say self.elevator equals elevator. Elevator is just going to be integer 1, 2, or 3, or 4, I guess. That's important in the state as well. Alright, what else? So we need static method. Get neighbor. So we want a neighbor of the state where we've oh my god, I can't think. So we want to know the current floor. We want a list to take, and we want the destination. Okay, so this is going to say we take these items from this floor to that floor. We want to get a new state. We're applying that. So if we're doing this, it actually is better to just make this one big tuple. In fact, we don't need to keep doing this. Let's say it's fine, we can keep it like this. Alright. Alright, so in that case we could just say return self.floors equals other.floors and self.elevator equals other.elevate. Floors elevator. Okay, so if we do it like that, we can now index the floors. Let's say 0, 1, 2, 3. Okay. All right. Let's say temp floors equals list floor convert each of these to a list so I can modify them in place, and then we'll put them back to tuples when we want to tie it up again. So list floor or floor in range 4. List floor wait, no. For floor in self dot floors. So we basically take this but turn it back into a list. So list to take, we're saying we take from current, we take out these items. So for X in list to take has to have 1 or 2 items. It can't have 0. For X in list to take temp floors, so we take away from current. Okay, temp floors dot remove. Is that a command for lists? Not sure. X. Let me test this out. A equals 1. A dot. Yeah, you do remove. Okay, it's not efficient, but it's fine. All right. So, temp floors equals. Make this a list. Okay. And temp floors destination dot append X. Now return a new state using these modified temp floor 0. This is complex. I'm just defining the state. I haven't started writing BFS, so temp floors. Good luck, ChatGPT. Hello, DIJ. We've got quite a complicated one. It doesn't look like it's hard. It's just quite. For one thing, it was very wordy, and it mentioned a lot of stuff about radioactive isotopes. Once I finish this state, I can re-describe what the actual problem is, because it'll be clearer then. Floors, me. Wait, we don't need current. Okay, I think I've done that. Alright, so... Alright, so we've made a state. This represents 4 floors and a position of an elevator. So each of these floors contains a bunch of microchips or generators. An elevator is just a number which says whether we're on 0, 1, 2, or 3. So I've defined some basic methods like equality, hash. So we've got getNeighbor, which says we want to take a bunch of items from one floor, which is where the elevator currently is, and bring them to a new floor. So this should do that. It removes those items from the current floor and then puts them into the destination floor, and then zips it all back up again as a new state. So the original state is never modified. Okay. Now we need to actually write the actual algorithm. So our input, I don't think we even need to parse this. We can just say we've got S generator, S microchip. Okay, so I might as well. Okay, so I'll just make these tuples. Well, I'll just make it a string with 2 characters. There's always 2 characters. So, start equals state. So we've got. What have we got? First floor, SG, SM, PG, PM. SG, SM. Okay. Second floor. TG, RG. RM. RM, CG, CM. RM, CG, CM. RM, CG, CM. Alright. Third floor is just TM. And then the final floor is just empty. And the goal state is where they are all. Wait, our elevator starts on. Let me check the description. First floor, okay. So start 0. And the state we want to end up with is basically empty, 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 everything on the 4th floor. And our elevator would also be on the 4th floor. That's the goal state. We want to bring all these items up to the top floor. Okay. So we write BFS given a start, goal. Okay. Suppose we want to use a... Alright, let me think. Yeah, okay. So, yeah, use a queue. Put the start in there. Alright, while not queued or empty. Alright, so it's sitting on the start. Alright, what do we want here? We want the number of steps required to bring all of the objects to the 4th floor. Okay. I guess we want to keep distance table. Let's say dist equals start maps to 0. All right, current equals q dot get. All right, so sitting on a node which represents an arrangement of items on floors and current elevator. This could be done with A star too, but I think it's small enough that we don't need to bother. But A star would just use the number of matching elements. Alright, so current equals q.get. If current is goal, return dist current. That's what we want. The number of steps it took to get there. Alright. Okay. Now we need to find neighbors. Alright, so neighbor. Alright, let's just make a note here because this has a couple of steps. So neighbor laws equals empty list. So if current dot elevator is strictly less than 3, or say no, start with strictly greater than 0, neighbor floors dot end current -1, so we can go down by 1. And similarly, if it's strictly less than 3, we can go up by 1. Alright, so those are the possible floors. So for neighbor floor in, those 1 or 2 possible neighboring floors. So we're looking at for I in range length of current dot floors. So the current floor we're looking at is wherever the elevator is located. So we look at, so we're going to take all possible pairs of items in that elevator. Oh, hang on. Hang on. Okay, let me do this the other way around. Go through all possible floors. So, okay. So we need to build up a list of all possible groups of items to take. So groups to take. So either 1 or 2 items. Alright, first of all, why doesn't it like this? Because we... current dot elevator. My god, this is complicated. Alright, so now we need a new method which says, given a floor and the items on it, is that valid? Given our rule, we always have to have a corresponding generator for it. Let me explain it as I build it, it'll be easier. So, I think when I write all this, it'll just work. But this is probably the most complex problem I've had to think about writing. Just complex in terms of all the rules, but not complex in terms of the algorithm. The algorithm's just BFS, as it often is. Alright, define. Is valid floor. Okay, so given a list of items on the floor, is this floor valid? So for X in floor. So our one and only rule is, if we have a microchip, then we have to either have the corresponding microchip in the floor, or the corresponding generator on that floor, or no generators, full stop. So if 1 equals M, this is a microchip, so if So we want to say if... So return any... So return either the first character of this plus the letter G to mean the corresponding generator is indeed in this floor somewhere, or not any Z. There is not any item Z with G. There's no generator, so there's no item whose second character is G. Or Z in floor. Okay. I hope that is logically correct. Alright, that I get that out of the way, so I can just call isValidFloor from now on. Alright, so... Oh my god, alright, so... Back to this. So, we go through each item in this floor. We want to take that one item with us. So we say... temp floor equals okay, let's start making some variables here. Current floor equals this. Alright, temp floor equals current floor, a copy of it. Temp floor dot remove this one thing. If the result is valid, that means we're allowed to take that item out. We can now take it somewhere else. Ah, no, this is not quite right. isValidFloor. If... Yeah, so for each of these, if this doesn't hold, it's immediately false. And if we get this far, then it's true. We didn't find any violations. So I have to turn this inside out. So we say, so for each item, if it's a microchip, and this condition, if this whole condition doesn't hold, that means it's a violation. And we immediately say false. Otherwise, oops, why did I say while? Untrue. Alright, that's correct, I think. So we say if is valid for, we say groups to take dot append. Okay. That one item. Alright. Now we have to look at all possible second items to take from here. See if we can also take them along with it. So I'm writing so much without testing it, so at the end we're just going to have to test this whole thing, and it either works or it doesn't. I can't see a way of testing this intermediately. Alright, so for j in range starting from I plus 1. Alright, we make another temp floor. We take out I, but we also take out J. Alright, and now we say if this too is valid, then we put in this group with I and J both being taken. So either we take 1 or we take 2. Okay. At the end of this horrible for loop, we now have a thing called groups to take, which are all the possible groups we're allowed to take away from the current floor. Alright. Now, for group in groups to take, for the potential neighboring floors we can go to, of which there are 1 or 2, we see what would happen if we were to insert those items into that floor. So temp floor equals current dot floors neighbor floor duplicated. All right. For X in group, we add those to the temp floor. And now we say, if this is a valid floor, at this point we can say now we've achieved a final result. We've taken 1 or 2 items from the previous floor, we've put it in the new floor. Both the previous floor and the new floor are both valid floors. This whole state is valid. So we've found a new state. So new... Oh, but how do we... Oh yeah, we had a method for this, didn't we? Get neighbor, that's exactly why we made this method. So we do new state, let's say neighbor state. All right, neighbor state equals wait, why did I make this a static method? This shouldn't be a static method. Okay, equals current dot get neighbor list to take. So list to take is group Destination is neighbor floor. Oops. That's just it, isn't it? This does all the heavy work here. So that takes them out, puts them in. And then it changes the elevator as well, which is also important. Alright, so we've got a new state. Now, if we've already seen this state before, if neighbor state in dist, then skip this one. Alright. Otherwise, this is a fresh state. It's one distance away from our previous state. So dist neighbor state equals dist current plus 1. And then just put it in the queue. Oh, is that it? God, look at this. The very final thing we want to do is just print BFS of start and goal. Alright. Now we just run this entire thing and deal with a million errors. I've not tested any of this. Current plus 1. Oops. Okay, that's an error. Neighbor floors dot append. So that should be current dot elevator. Tuple object has no attribute remove. Yeah, we do need the state to be tuples, so this has to be a list. So whenever we make a temp floor, it's going to have to be list. All right. $37. Only a couple of errors, and now I've got 37. Could that work? It's going to be a nightmare to debug if this is wrong, but it's very likely that it could be wrong. 37. Oh my god, thank you. First try. Alright, third try actually, but there were 2 minor errors. My god. That's not a hard problem to solve. It's just a hard problem to unpack. Now, I have doubts as to whether ChatGPT can solve this. I know I've had doubts before, and I was proved wrong, but this time my doubts are stronger, because that was a nightmare to parse, but also the input parsing is going to be difficult, because I didn't even bother writing a parser for the input. I just manually change them to SG, TG, and stuff. We'll see. But we don't need to do that yet. We can go into part 2. Man, what's part 2 going to be? Oh, just modify the starting state. Okay, interesting. Does that make it much harder? Alright, let's read this properly. So, you step into the clean room, separating the lobby from the isolated area, and put on the hazmat suit. You notice some extra parts on the first floor that weren't listed on the record outside. EG, EM, DG, DM. Minimum number of steps. Okay. So if this is coded correctly, it should just work. It looks like it's going to take a much longer time. So we could switch to A star if it takes too long. But so it says EG, EM, DG, DM. EG, EM, DG, DM. And that all goes in to the goal state. Alright. Come on, just work now. We can run both of them. It'll take a while. Let's just leave it for a while and see. Otherwise, I'll switch to... I'll add in A star. It's only a couple more lines to add for A star, but... I mean, normally they don't really expect you to know or how to put together A star for these Advent of Code problems, but once or twice it did help, even though there were other solutions. Okay, it's definitely taking a longer time, but we can give it a couple of minutes. But yeah, I think A star is probably the key here. So A star, what would we use for the heuristic? So it would be just Hamming metric, number of matching items. Or no, not Hamming metric. So basically the total sums of distances of all the items from floor 4. Because that's how many steps in a minimum path. That's a lower bound on how many steps it would take to get all the items up, wouldn't it? In fact, it would be like 2, 3, 4, 5, 6. It'll actually be double that, but not quite. We could just go with that. Sum of distances. But in most cases, it would be... Doesn't look like it's finishing. It's still running, so... Alright, we could start typing in some A star stuff then. So we call it A star. So we need priority queue. Okay. So again, we put start. So let's say, all right. Define H given a state. So we'll just go with the distance. So for I in range, let's say 0, 1, so in 3, because we don't care about what's on floor. Total plus equal, so it'll be 3 minus I. That's the number of floors we need to go up, multiplied by length of state dot floors I, the number of items in that floor. Return total. So here we put start H. So when we get the lowest value. So you put the H first. Wait, there's no H, hang on. H start. $61. It just finished. Since I'm so close to finishing the A star, I might as well just finish it. So 61, just keep that in the memory banks. All right, so still keep dist. So we say while not q.empty. So ignore the heuristic. Current equals q.get. If current equals goal. Yeah, this is correct. Return this to current. Neighbors is the same until we get to here. So okay. If it's in dist. So instead of this, we want to say if neighbor state not in dist or neighbor state, hang on, or we found a shorter path. Or dist of current plus 1 is actually strictly less than what we had before. Then we set the new distance to neighbor state to be that. Then we do queued up put, and we want to use the heuristic h of neighbor state. Is that all we do? So the closed set is essentially dist. I think we need to say if it's goal, yeah, we still return distance to current. There's something else we need to add here. What is it? So if this is not quite. No. We don't put. All right, let's just say 0 plus, just to make sure we're doing current. We're doing f distance plus h distance. You don't use just the heuristic. You use the total distance to that node, and then the s plus the estimated distance to the goal. So this is wrong here. We need to do distance up to neighbor state plus the heuristic. That's the key. So now, if we take the minimum of that out of the queue, and it's the goal, we've guaranteed to find the best possible path to that. Alright. Right, so it's 61. Let's see. Yeah. They never like this when I do that. Okay, so let's say... say everything is less than everything else because it doesn't like comparing. Okay. Less than... Oh. Less than... No, do we need less than or equal to? Yeah. No, what is it? It's less than. Not supported between... What do I need here? I've got equality, I've got less than... Oh, it's LT. Not less than, not less than equal. Okay. Let's try this now. It's taking a long time. I thought it'd be faster. Alright, that was faster actually. Just a bit faster. Hopefully the 61 comes faster. Is this helping? Yeah, I think that 37 came faster. I mean, this heuristic is kind of roughly half what you actually need. Hello, I am KCK. What am I trying to accomplish? Oh, well, this was the most wordy problem, and it's very difficult to summarize, but basically it's a We have 4 floors. We have an elevator we can use to move between them. We have a bunch of items on each floor, and we're trying to bring them all to floor 4 in the fewest number of steps. There's one overarching rule which defines what items you're allowed to leave on the floor, which is similar to the old fox, cabbage, and the goat puzzle, where you're taking a fox, cabbage, and a goat across the river. You're not allowed to leave certain items with certain other items. That's the very basic summary of this. So I've written a kind of a breadth first search to search all possible moves. And I changed it to A star. I thought it would run faster, but it seems to not be much faster. Well, anyway, the breadth first search gave me an answer of 61, so let's test that now. Okay, it was correct. I just wanted to make it faster, but I don't see this A star finishing much faster. I think it's because my heuristic is too small. I can actually double it. Or say... Hang on, let's see if I can make this work. Yeah, because every item you need to bring up to the top floor, you'd actually have to take double the number of floors, because you have to come down that many floors to pick it up, and then you'd have to bring it up. Oh, but I'm not accounting for the fact that you can bring 2 items at a time. Ah, that might be why it's slow. Because it is... This heuristic is actually wrong. Or it's not... What's the term? It's not... Oh, I forget the term now. A star heuristic. It's not... Admissible. It's not admissible because actually the true number of steps you need to bring it up to the top is half what I remember doing, because you can bring 2 items at a time. Okay, let's fix that then. So we go to our heuristic here, return total of the 2. Try it now. Now it's still okay. Now it's admissible, so we're gonna get it's gonna be correct. What I was doing before might not, if it was just wrong. It wouldn't have returned the minimum, or most likely it would not have returned the minimum. So now this is correct, as it's an underestimate. Now the question is, does it actually get the answer? Can leave it for a minute or 2. Now, this is now an underestimate rather than an overestimate, but it's still kind of way under because, okay, it takes that many steps to bring items up, but every time you go to fetch an item, you have to bring your elevator back down. So you have to add in the number of steps it takes to bring the elevator back down. So let's try and account for that. So we say we add the number of steps to bring it up, but also add in the number of I mean, essentially, we're just multiplying it by... let me think. I think overall it balances out to be total times 1.5. It could be a floating point number, that's fine. Because it's like... if you've got 2 items, then to bring them both up, it would take... so if it's distance x from the goal, it takes x to bring the elevator down, and an x to bring those 2 items up. So it's 2x... wait, what? So it's just you just multiply by 1. Wait, so it's x to come down, x to bring those 2 items up. So it takes 2x to bring 2 items. So it takes 1x to bring 1 item on average. Okay, but we can do... but we also have to account for the fact that the elevator starts low down, so we have to do... just subtract 3. Make sure it doesn't go below 0. Alright, I think that's the final. Okay, try this. So I think that is admissible now. We're as long as you subtract that 3, you avoid the situation where you're... okay, got 37. I'll leave it for a couple of minutes then. Alright, so anyway, the next step is to now see if ChatGPT can solve the same problem. 37, yeah, it did seem to be quicker. Yeah, it's kind of hard to get my head around this heuristic, but I think what I've written there is now admissible, but also very close to the true estimate, the true average. So it might be good. I mean, okay, aside from that, I can't think of any way of doing this problem better, because it really is a search problem. And A-star in general is usually kind of like gold standard. Unless you have more data. I mean, this thing I'm doing here is a bit bulky, but I don't see any way around it. Like, I'm creating a completely new state, describing what all the floors looks like when I move an item. But you have to do that, so... Hello, Amara. Did I write A-star correctly, though? I might be duplicating some... No, because if I'm checking, if I've found a better distance before, then I'd skip that state. I don't put it in the queue. But I might put one state in the queue multiple times with different distances each time. So when I pull something out of the queue, the first time I get that item, that's the best route possible to that node. But all the other all the other entries are still there with worse distances, and I'm still dealing with them. That's where I'm losing computation. So I've got to... What do I need here? I need a closed set. Which means... Yeah. You always have a closed set. So... when we've pulled out current, that is now the absolute shortest route to current, guaranteed. So we now put it in closed set to signify that. So if current was already in closed set, that means we've done it before. So skip this whole process for this current. And down here we can say, oh no, it's accounted for already there. All right, let's try that. All right. Should now be avoiding duplicate states with differing distances to them, and only dealing with the shortest path to that given state. Maybe there isn't really a way of massively speeding this up. I think you just got to let it run for like 5 minutes, no matter what you do. A-star might be a bit faster, but not massively. Maybe there's something clever you can do with Alright, well, I'll leave that running. Just... I'll be content if it just gives me the answer again, but it's probably not much faster. Okay, we've got to ask ChatGPT to solve this. I will be really impressed if it can solve this, because that was a pain to unpack. So, as before, we say... Can you write Python program all right. Now we just copy this whole problem, which was quite a tough read, to be honest. Can it even fit? I think there's like a limit to how much we can paste, I'm not sure. No, we can fit it, okay. See, I think ChatGPT will struggle even with the parsing, because from this example alone, it's not... Okay, that's what you parse. If you want to parse. I didn't bother parsing it. I just kind of directly typed in HM, HG for what I was reading here. But ChatGPT has to parse it because... well, I could... Nah, we'll have him parse it. He might get confused by that input and not understand what the format is. Oh, okay, let's just try it then. Oh my god, he's starting already. Okay. From collections, import DQ, import heap Q. Okay, fine. So he's going for BFS, I guess. Valid flaw. The flaw is valid if there are no generators without matching microchips. Wait, is that what it means? Hang on. No. He's got the wrong definition of valid. If you have a generator on a floor by itself and a microchip on its floor by itself, that's fine. What you can't have is a microchip without its corresponding generator, but with some other generator. That's not allowed. So I think he's got the wrong definition of... Well, at least the comment is wrong, but his code might be right. Unpaired microchips equals... Alright, I mean... I don't know. Yeah, the code might still be right. Neighbors. Yeah, 1 minus 1. Move 1 item, move 2 items. Yeah, this is good. Steps plus 1, steps plus 1, yeah. Alright, he's done a heuristic. What is this heuristic? He's actually distinguishing between G's and M's. Does it matter? If it's G... you add 2 times the number of floors. Fine. And if it's M, you subtract. Why? No. If it's M, you add. If it's G, you add. But what's this thing here? Oh, if the corresponding microchip is on the same floor as the G, then you can move them together. That's what he's saying. Why? Wait, but that fully cancels out that. What? So the total net contribution is 0? I don't know. That doesn't sound right. I don't know. Maybe ChatGPT is just way smarter than me. A star search. He's used A star. Okay. I normally use priority queue, but I suppose you can use heap queue. Okay, I mean, we'll see if this is correct, but I'm impressed so far. This is some pretty complex stuff here. All right, let's test this out. Oh man, it's still running. My A star was not very good, was it? I think the heuristic is a very tricky thing to figure out. Let me switch the windows. Oh. Damn it. ChatGPT timed out. The code is incomplete. Oh, and my program spat out 61. Okay. That took like the same time as the BFS, so the A star wasn't very good. Let's see what ChatGPT can do. So the main function he didn't finish writing. This is an issue with the website. It very frequently times out in writing these codes. Your main... Okay, let me switch back to... You kind of, unless you're paying for like the premium version of ChatGPT, you kind of have to just break things up and say, can you give me this section again or something? Your main function didn't finish generating. Please give me just the main function again. You have to do stuff like that in order to... Is that it? Hang on, parse input. Wait, you already wrote parse input? I don't think... Alright, okay, let's try it, but I don't think that'll work because he hasn't written parse input. Has he? Unless I missed it. Alright. Yeah, there's no parse input. I don't think he understood what I asked there. I'm saying, just give me the main function you were going to give me before. He's given me a main for some other program. Oh, great. Your main function doesn't match the previous code as you did not define BFS or parse input. Please give me the main function for the first piece of code. Oh, now we're talking. Colors? He's doing graph coloring now? What the heck? Not bicolorable. What the heck is this? This has nothing to do with... He's not parsing the input. N is int input. Yeah, no, there's no integers coming in the input. Where's he getting this from? That's annoying because he might have had it correct in the first one, but it's just timing out. Alright, maybe I'll just ask him to just generate this code again. Alright, he's generating it again. Please finish this time. It's gonna be a long program no matter what. This problem needs a lot of work. So this is where I hit a bit of a roadblock in testing ChatGPT, unless I upgrade to the paid subscription, but it's not cheap. It's like $20 a month. Or you can pay according to how much you use if you're using it for like business purposes and stuff, which could work out cheaper. Just small amounts of usage, but okay. This looks finished. Let's try that. Index. It is finished, isn't it? Yeah. What are these warnings? No, that's not an issue. No compilation errors, so there was list index out of range. Okay. I+1 overflow on the len. Hello, AVG dev. Is that meant to be read average dev? I birds +1. But yeah. I mean that is where the out of range is happening. All right. Well, all I can do in this test is to just tell ChatGPT the traceback, but not try to fix it myself. So that makes it fair. So let's just. Okay, nuance is better, but ready to ask a follow-up question. Okay. I am getting the following error. Please fix this. You are trying to access. No, it's not me. It's your code, ChatGPT. To fix this error, you can add a check. But that's not actually fixing the root of the error, is it? That's using the ostrich algorithm. Bury your head in the sand. If you're using an index out of range, then something's gone wrong in the first place. So, I mean, okay. I'll try his suggestion. Maybe say it like, in the above provided solution, I'm getting the following error while running. But I think he's understood. I don't think I needed to word it differently. I think he's just not really solving the root of the problem. Just okay. I can try that. Let's try doing his suggestion first. I have a feeling he's not going to succeed on this problem, but I'll give him a few chances. So he said if. Okay. So this line here we need to replace with that. Stop iteration. I've never seen that before. What does that mean? Oh. Next can't be called anymore because it's run out of things. Let's just, okay, I'll tell him what this new error is, but I'll say, can you please give me fresh code or something? Alright. Come on, ChatGPT. I mean, he's written some pretty interesting looking code. It's just not yet working. Now I am getting the following error. Can you please provide a fresh Python program to solve the problem without errors? Please finish generating. Alright, let's have a look. Is valid. Okay, is valid looks correct. Oh, he's done what I did with the start state and the target state. It is so eerie when he does things that I do. I like, okay, I mean, they're sensible things, so it shouldn't be surprising that he would do the same thing, but it still surprises me. It's like, sometimes I think that's just my unique idea, and it turns out it's just a very common idea. Right, so, BFS, that's a pretty compact BFS, but term depth, next state, and get possible. Oh, because he's extracted get possible moves to here. I mean, that's, yeah, fine. He's using combinations. That's probably smarter than what I did. That looks super compact. He's not bothered with A star this time. Fine. Let's try this. I mean, you ask him several times. It's crazy how different the program is each time. Okay. Now, it's expected to take a long time, so I guess I should leave it running for a couple of minutes, or at least... on the first input, it shouldn't take... It should terminate within a minute, I think. So, we'll wait. So, most of this rests on get possible moves being correct, so... possible flaws... yeah. This is a smart way to write this loop. Take the possible items, possible flaws, and then use iter-tools combinations on the two. Instead of using a triple for loop like what I did. Okay. Hey, Radiant up. Nice shirt. Yeah, thanks. Yeah, this is my sitting indoors shirt. I never wear this outdoors. Is he not accounting for taking 2 items? It seems like he's only taking 1 item. Or I'm not really sure. Wait, what? Hang on. ChatGPT cheated here. I never told him the input. He's copying the input from someone who's used ChatGPT on this exact problem in the past. I never told him this. How does he know it's HGHM? That's in input.txt, which I have on my computer. He doesn't have that. Well, he shouldn't have that. That makes it hard to make it a fair test now, because that kind of, well, he's still solving it, but it's reading your HT. Yeah, I think a lot of people have been using ChatGPT to solve these advent of code problems, and that's just training him. Look at that, he's got it exactly right. Wait, what's E? Oh, that's where the elevator is. Yeah, I never told him any of this. Oh. And see, this is a problem, because that's not even my input. Everyone who uses this site gets different input. So whoever used it before, he's using their input, but this doesn't match my input. I don't have HG and HM. I've got SG and SM and PG. It's not even equivalent, because floor 3 has only TN in my input. But in his, it has a bunch of things. So I need to tell him off for that. Did it run? Where's my console gone? It doesn't matter, it won't be the right answer. Let's, okay. Where did you get start state and target state from? I did not give you that data. The program is supposed to... So yeah, he's not reading my HD, because that's not even what it was in my file. Read the data. Read and parse the data from input.txt. I assumed you had provided the start and target states as input. What? I didn't. What do you mean you assumed I had provided the start and target states? I told you from the start to use input.txt. Okay, fine. He's done this. That. Okay, we can change change that. Then that's no longer copying past status, so that's fine, I guess. So he wants to change this bit to that. Target state equals LM. Wait, what's LM? Or did I not copy it correctly? Ah, that's supposed to be on this line. What? Okay. Hang on. does not like this. LM plus M, LM plus G. LM plus M, LM plus G. Let's try running it anyway. This does match what he's got. What's wrong with this line here? It's got LM plus M, LM plus G, or LM in start state that, union that, union that, close brackets, close list. What's the problem there? Unresolved reference LM, that's LM. Did you forget parentheses around the comprehension target? What? Oh, I see. That's weird. Actually, yeah, you can't do that. You need that to be a tuple? Interesting. Well, I don't know why he's done it like that then. Okay, we'll let him off for that one because that was easy to fix. Still not working. I think this is a fail. Now I am getting this error. Please try again with a new program. And should not produce any errors. We'll see about that. It's what, 10 for ChatGPT and 1 for humans? Before this problem, it was 9 for ChatGPT, 1 for me. I've yet to decide on this one. If this code here fails, I think I'll just call it a fail. Doesn't seem to be able to give me a program that just runs and produces an answer, whether or not it's the right answer. Okay. Okay. Let's try this. List index out of range. It's this exact same error as before. Well, okay, what is actually the problem here? For iron range 0 length words, I think he just doesn't really understand what the format of the input looks like. And to be fair, there's not much of a description in the problem statement. Nevertheless, you still have to work with what you've got. So I think he's assuming a format which is different from what it actually is. Place comma with, and yeah. All right. I mean, I'll give him one chance to correct this, but I think this is the only chance I'm giving him. Let's say I get the following error. Please produce a new program which doesn't I think I think his biggest issue is he just doesn't know how to parse the input. I didn't even write a parse of the input, I just parsed it manually. Could I just... I don't really want to paste the input in. Oh, I could. I mean, okay, if you were using this to cheat at the competition, what would you do if you can't parse it? You probably would just paste in the input because there's only like 5 lines. Let's do that. Let's one last try. This time we don't tell him to use input.text. We actually just paste the full input in. Okay. I get an error. Please produce a new program which doesn't have errors and uses the following input instead of reading from input.text. Okay. Because that's short enough that you could just give him the input and let him write the full program. That's in line with what I did as well, so it's only fair that I give him a chance to do it this way. Alright. Okay, lots of similar stuff to before, that's fine. As long as he's got the right input. I think most of the time he was just parsing the input badly, so now he's got the input directly. Yeah, he's using my input instead of some other guy's input from years ago. Well, ChatGPT was only launched this year, wasn't it? Or last year? But he has probably been asked about old problems a lot anyway, so in the past few months. Okay. Right, here goes nothing. Alright, this looks good now because... Combinations missing required argument are. Oh, I think he's using an old... Yeah, I think I've hit this issue as well. I think combinations used to... In the old version of Python, I don't think... Well, okay, we'll tell him that, because that's something for him to solve. Good, but... Switch the windows again. Good, but I get the following error. Please produce code to fix it. We have to specify the length of combinations we want to generate using the... Yeah, okay, good. This is good. So I think... I can't remember. I think maybe it was an old version of Python that used that way of combinations without the R parameter, and you can't do that anymore. So change get possible moves to that. And that's fair enough, because, you know, Python programmers make that kind of mistake all the time. Place that. None. Okay, at least it doesn't error out this time, but it's producing none. It compiles successfully, but I just... Could you specify the version of Python for it to use so it doesn't use obsolete ones? Yeah, I probably could do that, yeah. Alright. Anyway, he seems to have adjusted it from the latest Python now, so the compiler will just get the answer. None. So he didn't return anything from the BFS, he just searched for the fun of it. Okay, fair enough. Return none if you don't find the goal. Otherwise, return steps. That's... What was he doing before? Let me have a look. No, he was returning steps before, so I'm not sure what the problem was there. Okay, alright, come on. I think I have to call it after this one. Unless it's some trivial error. No. He's always getting this next issue. Alright, well, okay. Let's see if he knows what to do about this, otherwise. Because this time we have the correct input. Now I get the following error. The error occurs because you can handle this error. No, I don't. No, don't. Wait. If he's failing to find a flaw with the elevator, that's bad. You shouldn't be handling that error. If there's no elevator, then your code's wrong in the first place. There should never not be an elevator, I think. At least according to my understanding of his code. Alright, well... Fine. Last chance, ChatGPT. But it doesn't sound like that's the solution. Why? What happened to your elevator? Why did it disappear? None. Nope. Still giving me none. Yeah, I think he's just going around in circles here. Still just gives none. Current state to the visited set before yielding the next state. Was he not doing that? Fine. Alright. I'm giving him too many chances, but to be fair, it took a long time to write my code, so actually I should actually give him a fair amount of time. No, don't change the whole thing. Change just the BFS to that. No. Like, if I look at the old BFS, he was adding stuff to visited, so I think he's just guessing at the problem, but that wasn't a problem. Yeah, I don't think even... Yeah, I don't think that was the problem. Okay, that's it. Still... Let's just make him feel bad. Still doesn't work. Well, you tried. I will go hire a real programmer now. All right. that was a fail. So the current score is, that's 11 problems altogether. So it's 9 points to me, 2 points to me, 9 points to ChatGPT. What was the other problem we failed on? Oops. Don't remember now. Somewhere around 4 or 5, I think. I'll have to look back at the videos, but yeah, he's failed too. At this point, I should probably keep a little score banner on my stream. Should keep a text with the results. Yeah, I probably should at this point. I thought once I had only one fail, it would be easy to remember. Now I've got to keep track. Where do you find new concepts to learn for Python? Well, I don't know. I can't really answer that. There's too many. Wait, so what kind of Python code do you mean? Because there's just too many different ways, different kinds of programs you could use Python for. Like Advent of Code is sort of puzzles, mathematical puzzles, which is fun and everything. It's probably quite different from what you would actually code in a software engineering job, because you write messy code, you write it quick and dirty, you just want to get a nice mathematical answer. But it does expose you to lots of concepts in lots of modules within the Python language, ones that you might not often touch. So that's good. I mean, every time I do these, I always uncover new things about Python. Leonardo's monorail. Oh, looking at 12. I think I've got to call it there. That took me just over 2 hours. Well, okay, with ChatGPT. Well, it did almost take me 2 hours on my own, so that's enough for today. So let's have a look at the old leaderboard. Yeah, 11 problems. I'm curious, how long did people take to solve that problem? 11. Okay, look, 11 has a bit of a dip in terms of number of stars, so there were fewer people able to complete 11 than many of the other problems. Alright, how do we see the stats for... Alright, here we are, 11. The fastest to solve both stars was 8 minutes 40. That's insane. What? I suppose if you've pre-prepared a generic BFS, then you could probably just copy and paste that in and then adjust the state, but the state is hard to handle on its own, but fine. I mean, that was a whole several minutes faster than second place. This was 2016, so this was before any form of ChatGPT existed. So this is when people actually had to program properly. And the top 100 goes to 2 hours 44 minutes. Well, I solved it faster than that, so I would have been in the top 100 had I known about Advent of Code back then. Yeah, I solved it in... Well, how long did I solve it in? Just under 2 hours, I would say. So, I don't know, 1 hour 50? That would put me at the top 60, 70 or so. I guess back then there weren't as many users of this site as there are now, so it'll be harder now. Like, this is just the second year it was launched, so it was still somewhat of a esoteric kind of thing, and only pro coders, well, just not many people in general knew about it, so there weren't many people in that leaderboard to begin with. Okay, fine. Oh, I see. This building here is the HQ. How were your skills in 2016 compared to now, though? Better, probably. I was still in my PhD, for which I didn't really use coding, to be fair, but I was practicing on the side, so I would say, and that was just before I joined Amazon. In fact, I think I was applying to Amazon in 2016. December, that's when this was, so I was literally interviewing for Amazon, so I would have been practicing these types of problems much more than I do now, because I don't really interview at such companies anymore. So yeah, I would say my skills were definitely better back then. Honestly, I think my skills peaked in 2012. That's when I did the Google Code Jam and I reached the quarterfinals. No, not the quarterfinals, not semifinals or something, I don't know. And I won a t-shirt. And ever since that year, I've been repeatedly entering the Google Code Jam and not getting anywhere near as high as I did then. So yeah, I think I peaked after university, my undergraduate, and just went downhill ever since. That's not unusual. That's I guess, I think a lot of people would say they peaked, while they were still in their mathematics or computer science degrees, because that's when you actually learn this stuff. After that, you don't write PFS anymore. You just use libraries that other people have written and unit tested extensively. Good thing Google cancelled the code jam. Yeah. I still don't know the reason, but I wouldn't be surprised if they are afraid that ChatGPT will ruin the Google Code Jam, because it will. ChatGPT is smart enough to solve Google Code Jam problems. I could even maybe do a stream series where I test out one of the past Google Code Jams, maybe the qualification round or something, or round 1A or 1B or 1C. But yeah, I'm pretty sure ChatGPT would be able to solve some of those problems, and that does actually ruin the competition, because what else can they do? The finals are held on site, so they'll fly the finalists into the office in Paris or wherever it was to solve the problems on site. So that's fine, but getting to the finals in the first place, you can't do anything but have it online. So yeah, I think competitive coding has just been ruined by ChatGPT. There's no other conclusion. There's no way around it. You can't. I mean, these problems are very smartly written, and they spend months designing these problems, and they're still solvable with ChatGPT. So there's nothing they can do to protect against AI solvers. But it might just be coincidence. It might be that they Google cancels everything. Every good product that we like and use, they eventually discard.